Many haloalkanes are used in industrial and household applications, and their uses are based both on their chemical and physical properties. And so we'll talk about the most common uses of haloalkanes. They're used quite frequently as solvents, and a whole number of haloalkanes are used as solvents. This is based on the fact that they're good solvents that dissolve a lot of things, and we can use this in academic settings, but these can also be used for things like dry cleaning or chemical industry. And even for using things like making decaffeinated coffee, although which is based on the fact that methylene chloride, for example, could easily extract the caffeine out of the coffee bean. However, there are certain concerns with using halogenated solvents, and those are mostly their irritating properties, and for some of them, their carcinogenic properties, which have been proven, although this presents a big problem. In addition, some of them are damaging to the ozone layer as well, and have been essentially outlawed, such as carbon tetrachloride. But among the solvents that are still commonly used, we find chloroform and methylene chloride, but also things like 1,1,1 trichloroethane and so forth. And again, methylene chloride and chloroform have been slowly phased out because of their potential carcinogenic properties, and largely replaced with larger, less harmful salts. They're also used a lot as reagents in chemical industry, but since this property is based largely on their chemical properties, we'll talk about it more in the lectures to come. Another use of halogenated solvents is as anesthetic. Traditionally, chloroform was used first, but its problem is that it's toxic, so it's no longer used as an anesthetic. But if you see an old movie and see somebody put a handkerchief stained in a liquid over somebody's nose, and then that other person passes out, that was typically chloroform. The chloroform has largely been replaced with a different, more complex halogenated ethane, which is called halothane, which is virtually non-toxic. And even other very simple compounds, such as ethyl chloride, is used as a topical anesthetic for the skin. Apart from its anesthetic properties, which are really beyond the scope of this course, the reason why this is a good topical anesthetic is it has very low boiling point, and so once you apply it to the skin, it evaporates very quickly and makes skin cold, which enhances the feeling of numbness, which is what you want in anesthesia. One more use of these halogenated systems is as the refrigerants. And the halogens are used in refrigeration known as freons, also known as chlorofluorocarbons, or CFC. They were hailed as a big breakthrough in refrigeration because they replaced ammonia, which was toxic and very irritating. They're virtually non-toxic, and for a long time they were considered like the perfect solution. But then it was realized that their diffusion from old refrigerators or air conditioning systems into higher layers of atmosphere damages the ozone layer. And in the 80s, I suppose, this became a big problem, which eventually led to the Montreal Protocol that severely limited the use of freons in refrigeration. The freons are routinely named by numbers, so this would be freon 12, and this really is the one which was the most damaging to the ozone layer. Largely now, things have been switched to other non-halogen-based refrigerants, or freon 22, which has a hydrogen atom in it. And those freons which do have hydrogen atoms supposedly get destroyed in the atmosphere before they reach the stratosphere where all the ozone is, and therefore not damaging to the ozone. Montreal Protocol, by the way, is a sort of an unusual example of a very, very broad international consensus on tackling environmental issue, and it's hailed as a big success in environmental conservation, where many countries came together and established these set of rules. Finally, one of the other common uses of halogenated hydrocarbons is as pesticides. Probably the most commonly known pesticide ever made is the compound shown here, which is known as Dichloro, Diphenyl, Trichloroethane, or much more commonly as DDT. This compound was discovered in 1939, which was a perfect timing for the war, and actually was instrumental in saving a lot of soldiers' lives in the Second World War, because soldiers that had to fight in insect-infested regions could easily keep the population of these pests under control. And it's really its toxicity in humans is actually very low, but its toxicity in insects is obviously quite high. And for a long time, it was regarded as this miracle cure, and really its use has been attributed with saving a lot of lives in the years since its discovery. But it was banned in 1970 by Environmental Protection Agency when it was realized that it degrades very, very slowly in the environment. And so since it doesn't degrade, it starts accumulating, and its toxicity, although low, starts getting more and more pronounced. Not so much in humans, but in many species of animals, especially some endangered animals that suffer from these accumulating concentrations of DDT. And so it has been largely replaced with other pesticides, many of which are not halogen-based, but some are, such as l13, which has this very interesting and highly bridged structure. And it has multiple chlorine atoms with bridge-shaped carbons. Another one is lindane, which is this interesting cyclohexane derivative, which has 3 axial and 3 equatorial chlorines. And finally, we will end with this topic with just mentioning one not so popular use of pesticides. This is the Agent Orange, which was used, fortunately, during the Vietnam War for basically induce deforestation in Vietnam, so that Vietnam troops could be more easily spotted by the American planes. And this was basically a one-to-one mixture of these two pesticides. As you can see, both of them are based on polychlorinated arenes in this. Well, let's finish here when it comes to topics of using hydrocarbon derivatives that are halogenated. And in the next step talk, we'll start talking about their physical properties.